Hi, my name is Raimundo Mirisola. I work on Google Software Engineering, and I'm here to talk about how to privately count how many people watch ads. I'm speaking in support of the WFA project CMN Halo. So this is a cross-media measurement project that the World Federation of Advertisers is hosting to advance the capabilities of privacy-preserving cross-media measurement. And just to kind of illustrate what is the problem that we're trying to solve here, imagine you're an advertiser and you're running a campaign across 3 channels, red, yellow, and blue. And in each of these channels, you're reaching 100K, 200K, 300K people. So the question that you're trying to answer is really, how many unique people did I reach across these channels? So you need to deduplicate the people that you're reaching across the multiple channels. And you as an advertiser want to essentially optimize this graph. You want to maximize the number of people that you reach effectively across multiple channels. So that way you optimize your budget. That is also happens to be good for the users because they end up seeing less ads across all these different channels. So the challenge is, how do we enable this? Because if these 3 channels are 2 different websites, for example, it's not possible to just combine kind of the IDs that we see in each of the channels, because that would kind of violate some of the privacy policies of this website. So one way you could go about this is to use something called sketching. And an example of this is Bloom filters. So these are like special data structures that you could build in order to represent a set. So this data structure, you would insert all the IDs that you see in each channel, and then you would send them around and then use them to deduplicate the reach ad. And you would get something that would look like the graph on the right that shows a reach and frequency histogram. So the problem is, we want to use differential privacy. So one way, this differential privacy is really a promise that we make to the users to minimize the risk of identification. And the way differential privacy is usually implemented is by adding noise to the data. So one way to illustrate this is that if each channel adds some noise to the input data, and then kind of the output will have some noise that will make it difficult for people to be re-identified in a statistical sense. The problem with that is that if you add noise in this way, where each of the channels is adding noise before the data is sent around, which is kind of a version of local differential privacy, that noise tends to add up pretty quickly. So as you increase the number of sets that you want to join, and this is based on research that we have been doing in the WFA collaboration group, we can see that the noise adds up to a point where it's no longer usable. So if we want to extend this to a large number of publishers, then this approach would not scale. And this is exactly where MPCs can help. So what MPCs allow us to do is to process the data in a way that, either by using homomorphic encryption or other MPC techniques, the intermediate data is not decryptable or not accessible to the nodes that are processing the data. But we can guarantee that the final outputs have the differential privacy noise necessary to guarantee the privacy requirements, and do it so in a way that we only need to add the noise once. So the noise doesn't add up multiple times, which means we have a much stronger utility of the system. And there's a link at the bottom that you can follow to see more details on how this particular MPC protocol works. So I guess some final notes on the user privacy trust model. So imagine kind of there's users that already trust kind of these channels, right? So they trust these different websites with their privacy. But not every user goes to every site, and not every user trusts every site. But if you on the right-hand side have an NPC between these parties, which have a malicious majority guarantee, which means you can trust the system as long as you trust one of the participants, then it would follow that if you trust any of the websites that are participating in the NPC, then by a transitive property, you should trust the NPC. And this is the kind of the magic that I think the NPC brings to the table, that we can scale privacy, and we can meet kind of the user requirements. So I guess a final note, why this is important, why are we doing all this? Well, we want to help advertisers optimize their campaigns, and what that means is users tend to see less ads because their campaigns are optimized. And the advertisers being able to optimize their campaigns means they will encourage healthy competition between the different websites and different publishers that participate. So I guess conclusion is, NPCs can enable privacy preserving ad reach and frequency optimization.